This is Professor Dare of Sites, Discrete Random Variable Distribution. This video shows how to create a probability distribution for a discrete random variable using Microsoft Excel. In your first column, the random variable x, you put its values of the different possible outcomes. This data shows 1 through 5. Your data will be whatever the outcomes are. The blue cells indicate that you can enter your data without having to change formulas all the way down through row 30. There are some formulas in the spreadsheet that reference row 30. And if you go beyond row 30, you'll have to change those formulas to reference where your data ends. If you add more data and you don't go all the way down to row 30, there you have some blank cells. The formulas in the spreadsheet will work without needing any change because blank cells are interpreted as having a value of 0, and they do not impact the results of these formulas. However, one important point, for each value that you have, you must have its associated probability. It must come in pairs, and this column here, column D, also must appear for any data that you have. If you add more rows here, you can extend column D by taking the little square extension in the corner here and dragging down however far your data goes, and you'll get it extended. Where did these come from? Remember, 0 for the x, and this column is taken the x, which is 0, minus the mean over here, which is slightly less than 3, and squaring it, and you'll get something slightly less than 9. Backing that out and going back to how it is right now, the first thing we want to go back to is after the outcomes are entered for x, you enter the probability of each one. And over here, check, there's a sum of the probabilities, and it needs to add to 1, as this comment mentions here. If it doesn't, then you've made a mistake in your distribution, in your data as a mistake. The next thing to look at is the expected value, which is another name, a more meaningful name for the mean of this distribution. It's calculated as a sum of products of the outcomes in column A and their probabilities in column B. Multiplying across each one to get, in this case, it would be 5 products, and they are then summed or added together to give you your expected value. The variance, sigma squared, references column D. We'll look at column D next before we go back over here. Column D is deviations between the outcome x and the mean, and it's the square of those deviations. Looking at the first row in column D, you see A2, which is the x value, minus G3 is the mean, the expected value, and the dollar signs around the G and the 3 indicate that this is not a relative cell, it's a absolute position cell. The different formulas, when you drag down in column D, the A part is relative and automatically adjust. The expected value is fixed for all of them because of those dollar signs. Going back over here, the variance is the sum of the products of column D items with column B items. The square of the deviation times the probabilities. All those products added together gives you the variance. Finally, the standard deviation, as always, is the square root of the variance.